Right, we're going to start by looking at a nice, simple, and innocent piece of code. So this is a retrofit service, Pokemon service. It's going to fetch some Pokemon over the network. Looks nice and simple, but what exceptions can it throw? So if I attach the emulator and turn off the network, turn off the Wi-Fi and the mobile data, then I can get a unknown host exception. If I misconfigure my certificates, then I can end up with an SSL handshake exception. And if I'm playing around with the proxy and intercepting responses and I take too long, I could get a socket timeout exception. And last of all, if I misconfigure my JSON handling or some data comes back over the network that's not in the format that I expect, then I'd end up with some kind of JSON data exception. So a lot of complexity from this function that seems very, very simple. And contrast that with the return type of the function. So the return type is Pokemon response, and we get very, very strict type checking on that. So if I try and assign the result to a string, the compiler will complain. So basically we're very, very strict with our return type, but there's a lot of complexity and a lot of unknowns around the exceptions. So you might say, okay, well, that's a problem with retrofit, and maybe you'd be right, but it actually happens in other libraries as well. So if we look at another so-called innocent piece of code, this is a DAO, data access object for Room, which is the abstraction over the SQLite database that you get as part of Jetpack. And if we ask what exceptions this can throw, it's actually a very good question. And you can see someone's asked this on Stack Overflow, and it's got quite a few views and quite a few upvotes. Seems that Room has its own exceptions that are documented in the API, but there's also a number of exceptions that are undocumented. So for example, in this comment, it explains that we can end up with a SQLite constraint exception in a different scenario, and this is actually undocumented. So again, it's very, very confusing, and there's a lot of potential for mistakes. So we can complicate it further when we talk about concurrency. So in Android, we don't want to block the main thread. We want to offload work to another thread, and then when that work is complete, we want to see what errors have occurred or deal with the success. And there's been various solutions in the past for this, and they all have varying ways of dealing with the errors that come from executing the asynchronous code. So we're going to have a look in the context of an Android app. So this is the Pokedex app by a developer called Jaewong. So Skydoves on GitHub. Very well done Android app. And it follows the basic Jetpack architecture. So if you look on the top left there in bright green, you have the activity or fragment. Then the fragment observes the view model in blue there. View model exposes live data for the fragment to observe. And then we don't want the view model dealing with the implementation details of managing different data sources. So the view model talks to a repository. The repository is an abstraction over two data sources. The one on the left, which is in purple, which is the Room, the local data source, which is backed by a SQLite database. And then on the right, there's a remote data source in pale orange there, which calls through to a web service. So pretty standard architecture there. And the use case we're going to look at is when we load from the network, then we want to save what we got from the network into the database and finally present that to the user. So one way to do that would be to use callbacks. It's probably the old way of doing things. So if we do that, our Pokemon service looks something like this. And our DAO, we're just going to write some synchronous code or some blocking code. If we try to use that to write a repository, then we end up with this code here. So immediately you might say this is very ugly. You can say it's got a shape like reuse fireball, where it's got this arrow shape continuing nesting rightwards, drifting rightwards on the page. So we're going to say that the fireball shape represents cognitive complexity. It represents code that's difficult to reason about. So it's something undesirable. So if we want to get rid of that, the next solution that became really, really popular is RxJava. So RxJava, our Pokemon service would look something like this. Then our DAO would look like something like this. So immediately you can see that we've had to wrap the return type in a single for above. So single has on success and on error, and then completable for the one below. So completable just means we don't care about the result. We just care about whether it's completed or whether it's failed. And then if we try to write a repository, we end up with something like this. So call through to fetch Pokemon list on the Pokemon service, and then use flat map to perform some extra work. So flat map is a combinator here. And then what work are we going to do inside the flat map? Well, we're going to insert into the database and then finally just return the results that we got. So you can see there's much less nesting. It's much cleaner than the solution using callbacks, but there's still a little bit of nesting using the flat map there. So then along came, oh yes, let's look at what this looks like in the view model. So in the view model, we have Pokemon repository fetch Pokemon list. And we can say do this work on the IO scheduler, observe on the main thread, and then in order to use this, we have to subscribe. Subscribe has two parameters, and on success. So on success, we're just going to update the view state, and then on error. So notice in the on error that there's an implicit lambda parameter it. So we only know that it is assignable from throwable. We don't know any more information about what type it is. So normally we end up with some checking at runtime of the type of the exception there, and then handling it in different ways. And finally, we also have to manually manage the subscription by adding it to a composite disposable and then clearing it when the view model is cleared. So then along came coroutines. The service looks like this, and the DAO looks like this. So we've just added the suspend modifier in front of the function. We don't have to wrap the return type anymore. We don't have to worry about singles and completables and so on. Then if we go to write our repository, we end up with something very, very nice. So we've got rid of all the nesting, basically. We don't need to worry about combinators like flat map. We can just write imperative code and use the result. But when we get to the view model, we have some good news and some bad news. Good news is we don't have to worry about managing a subscription. We don't have to worry about clearing disposables or anything like that. But we still don't have a good way of dealing with the exceptions thrown by the call to the repository there. So one solution would be to use try catch, but you might say that's a little bit inelegant. That's kind of like going back into the bad days where we had Java and checked exceptions, and we'd have to use try catch a lot. So we could attempt to clean that up and get rid of the try catch. So here's one solution that you get out of the box using coroutines. So we put the call to the repository inside the list, but we're still ending up with this catch here where we don't have any real type safety. We just know that T, the lambda parameter there, is of type throwable, and then we have to do all this checking at runtime what type of throwable it is. So can we do better? So one solution here is to bring in paradigms from functional programming. So Arrow is a functional companion to Kotlin's standard lib. So you might think of it as something that supplements standard lib with some basic abstractions that you would need to do functional programming. You can bring it into your project with a script that you could put inside your build Gradle if you're still using Groovy for your Gradle script. And we're going to use a abstraction from Arrow called either. So either is a sealed class. You can see there in the declaration, there's two type parameters, A and B. So A is called the left and right, and B is called the right. And left represents failure and right represents success. So we can, if we look at the code, line 1, we can see we can create an instance of either a throwable or a string with a constructor. And similarly, we can create a left from throwable. Now, if we take that right we created in line 1 and then perform some computations on it using map, so just adding to the string, we end up with either right or value ABC at the end. So map here means map on the right of the either. So that means that either is right biased. We were talking about map with either, we're talking about mapping right. If we take the left in line 2 and try and perform some computations on it, so what happens there is short circuiting. So the computation does not proceed, it just, the original value passed in for left is just returned at the end without the mapping occurring. So how would we go about applying that to our Android app? Well, let's start by enumerating all the different exceptions we might get in our data source. So remember that data source encompasses network and local. So we're going to say in our data layer, we can have connectivity exceptions, internal server exceptions like from a 500 response, and then database exceptions, which are errors from writing to the disk, foreign constraint exceptions, and so on. Now we can write a remote data source that just wraps a Pokemon service. So the return type is either a data source exception or a Pokemon response. And here we're going to use either.catch. So catch will call a block of code and then wrap any exceptions you get. So those exceptions become the left of the either, and then the result will become the right, obviously. So either.catch is great at your application boundaries where you're calling through to some external code where you don't know what exceptions might be thrown. And it gives you an opportunity to map any exceptions that you get into an exception that you own. So to prevent the exceptions from bubbling up through different layers. So we don't want exceptions from the data layer bubbling up to other layers like the domain layer and the presentation layer. So now our repository looks something like this. So we're going to fetch the Pokemon list, and the return type is a domain exception or a list of Pokemon. So this is because the repository is a domain layer. And one way to do things would be to call through to the Pokemon data source through the network and then map any exceptions to domain exceptions, and then use flat map to perform some extra work. So inserting to the database and again mapping any exceptions. So here we've used combinators like flat map, and you can see we've almost gone backwards from the world of coroutines where we had this nice imperative code. We've put a bit of nesting and cognitive complexity in there. So that's not ideal. I wonder if we can clean it up. So it turns out we actually can. We can write a high-level function fetch Pokemon list, and that's going to delegate through to a private function and then map any exceptions that we get into domain exceptions from that. This private function has a return type of data source exception, either data source exception or list of Pokemon. And we're going to use this either monad comprehension here. So monad comprehension is a scary word, but you can kind of think of it like a sequence builder. A sequence builder gives you a block in which you can compose a sequence very easily using yield, and the monad comprehension gives you the same thing. It gives you a scope in which you can access code that calls through to ethers and then write in a imperative style without having to use flat map or map left. So first thing that we're going to do in the block here is call our Pokemon data source. And you can see we've used bind there. So that function bind means basically bring the result of calling the ether into the scope, into the monad comprehension there, and use it. So now that we've bound the response there, we can unpack it within the scope and then insert it into the database. And again, we need to call bind because we're calling through to an either. And this binding here is type safe. So the reason it works is because Pokemon data source.fetch Pokemon list and insert into DB both have their left type parameter bound to data source exception. So if we mismatch, if we have two calls where the left is bound to different exceptions, then you can have the type inference fail. So it basically ensures that we're doing things in the right way with our exceptions there. So you might be wondering what this looks like inside the view model. So in the view model, we can exit the world of exceptions of either using fold. So fold has two parameters, an if left and an if right. So remember, left is failure, right is success. And you can see for the left, we've got type safety. So we can use an exhaustive when. We know that the left is going to be a domain exception, and we can perform the mapping without having to guess at runtime what exceptions are going to be thrown and wondering if we've handled them correctly. So that was either. And one of the distinguishing characteristics of either is that it short circuits. So here inside this monad comprehension, if the call to fetch Pokemon list fails, then the rest of the computation will discontinue. So it's short circuiting. But what if we don't want short circuiting? So a use case where we might not want short circuiting is if we want to accumulate errors, run a computation and then accumulate errors over the computation and then show them at the end. So an example in an Android app would be, say, a screen where we get to name our Pokemon and then click submit. So if I enter a bad name for a Pokemon, so David with lots of D's on the end is a bad name for a Pokemon, I get two errors. It's too long and the suffix is incorrect. We want a Pokemon to have a nice, cute name, and this doesn't meet the criteria. So how would we go about representing the state inside the view model for something like this? So we can start by enumerating our errors. So Pokemon name can have a bad suffix, it could be too long, or it could be empty. These are all errors. And then we can model that as a state. So for our state, we're going to say a Pokemon name represents a validated Pokemon name, or a name suitable to send over the network or to put inside the database. And then errors is going to be a list of errors we want to show to the user, telling them why their name is incorrect. And we want to represent no opinion. So no opinion is when the user hasn't entered in a name inside the edit text and they haven't clicked submit yet. So No, it's called no opinion because we're not expressing an opinion about whether that name is valid or not and whether it has any errors. So we can easily represent that with a naive modeling. What about the validated state? So yes, we can represent that as well. So here, Pokemon name is Bulbasaur, which is valid, and then the errors are empty, of course, no errors. And then what about the invalid state? So we can represent it as well. The Pokemon name is null because we haven't got a validated Pokemon name. And then there's a list of errors, invalid suffix, and too long, which we display to the user. So the disadvantage of doing it that way is that we come up with this meaningless state. So here we've said, okay, the state includes a validated Pokemon name, and it also includes errors. It also includes a valid suffix and too long, so that there's nothing to prevent us from creating a meaningless instance. Now we could, of course, try and clean that up by making the constructor for the state class private and then writing some kind of factory function where we throw if we encounter this meaningless state. But if we do that, we only find out at runtime that something's wrong. We'd rather find out at compile time with some kind of compiler error. So instead of, you might have noticed here that the list was kind of open to abuse. We can actually use this idea from functional programming called a non-empty list. We get this for free in Arrow, non-empty list of Pokemon name error, and we can abbreviate that to nil. If you try and make an instance, then with no members, then you'll end up with a compilation failure. And on top of that, we're going to bring in another extraction from Arrow called validated. So validated is like either, it's got a left and a right. Left represents failure and the right represents success, but the left is going to actually accumulate the different errors we get. And we can now represent our state like this. So Pokemon name is of type validated NEL Pokemon name error or a Pokemon name. And then we're making it nullable because we want null to represent no opinion. So the state where the user hasn't actually clicked submit yet. You might notice there's nested type parameters there. So nested angle brackets are a little bit inelegant. So we could clean it up using a type alias. And again, we get that for free from Arrow. So instead of making the type parameters nested, we can make them sisters. And then we end up with this nice way of representing our state. So now we've got a state, now we've modeled that. How would we write the code to validate? So we can write that as extension functions on string. So we get a string from the edit text, and we're going to perform a validation called validated length. Return type is validated nil of Pokemon name error or string. And then we're just going to use pattern matching inside the function. So when the length is less than 16, we're going to call this extension function valid. So valid is just going to wrap the string receiver, the this, inside a validated.valid, so the right. Otherwise, we take a Pokemon name error of type too long and then wrap that in an invalid NEL, so an invalid non-empty list. Then we can do something very, very similar for the suffix. So we're saying that a Pokemon name has to end with one of these suffixes here, otherwise it's not cute. And then lastly, we can check if it's empty or not using something very, very similar. So now we've got all our different validations. How would we execute them and accumulate errors over them? Well, to do that, we actually use zip. So we're going to call validated non-empty and then zip that with validated length and then validated suffix. Finally, at the end, we're going to combine all those by just wrapping the original string inside a Pokemon name, which represents a validated Pokemon name. So you might wonder how that plays out in practice. So we're going to write some code to execute that. So if I take the name Bulbasaur and then I call validate Pokemon name on that, I end up with validator.valid wrapping a Pokemon name of value Bulbasaur. And if I do this for this terrible name for a Pokemon, then I end up with validator.invalid. Why is it invalid? Well, there's a non-empty list of errors containing too long and invalid suffix. Of course, you don't need to model your domain like that. You could say that having a non-empty list as the left or the invalid of the validated is not right or not correct. We're going to wrap our errors inside a Pokemon name error, and we're going to have the reasons as a non-empty list there. So now validate Pokemon name would look something like this. So we perform the same zip, and then right at the end we map the left, the non-empty list, inside a Pokemon name error. So now if we run that code, then we end up with validated.invalid. Why is it invalid? Well, because we have a Pokemon name error. And what are the reasons it's invalid? Well, we have it's too long and it doesn't have the correct suffix for a Pokemon. So that was validated. I'm going to put the slides up on Twitter afterwards for you to have a look at. And that's the Twitter handle. Are there any questions?
So if people can post the questions in the QA area, I'll give you a couple minutes to write something. I'm kind of doing the same here. Feel kind of weird. I'm on camera, but I also am trying to write a question. But yeah, let's give everybody a couple minutes. And thank you, David, so much for a wonderful talk. Yeah. I guess, actually, if nobody's written a question, I could just pop my question. I'm going to try wording it. I've had difficult. I think for me, functional programming is like super powerful, and it can make like piping, like just piping stuff in your code, like I don't know, like it's a cleaner handling is how I feel it when I'm using a monad to distinguish like a success. Like I usually use it for more of the either example you were given, where it's like a success and an error case. And I found it super helpful for like actually like just making I guess error handling a lot simpler. But I've looked at Arrow a bunch of times and kept like walking up to it, looking at like just this beautiful library of so many options, and then thinking, there's no way somebody can hop on a project and understand how these things work. Like, so it's one of the, to me, it speaks like it's a very challenging choice to want to use this. I've opted in. I don't know if you know Michael Bull's Kotlin result library. It's basically like, yeah, like actually Adam Bennett gave a talk like long time ago here about how he was advocating for using that, because he was talking about using monads. And what I like about Michael Bull's library is it's very simple. There's no it basically just takes the either and just calls it error or okay. So it's just basically focused on success or failure. And that's the part of functional programming I find super easy to kind of understand. Okay, error, success. Well, handling errors is much easier this way. But when you start bringing in the rest of what Arrow brings forward, because Arrow is like that and tons more, it starts to get like, it's too much. And so I'm curious to your opinion on, do you think it's worth it? Like how do you, how can you comfortably incorporate Arrow and all of its functionality without overcomplicating your project and making it like incredibly hard to onboard people?
Yeah, okay. So basically to rephrase the question, like Arrow is a very complex library. How would we bring it into the project without make it impossible to understand the code and impossible to onboard people, right? Yeah, so that's a good question. So I would say that in defense of Arrow, it has become a lot less complex recently. So the reason for that is because they took away higher kinds. So higher kinds adds a lot of complexity, and we don't have that anymore. The main feature that Arrow Core is going to provide for you as an Android developer is just this either and the validated, I would say. It's just this type safe way of dealing with exceptions. So the other part to that question is, how do we onboard people? And I think this is a really really cogent point. So when we're making decisions about what type of library we use and what frameworks and what structure we incorporate for our Android project, we have to keep the level of the team in mind. So I've seen this play out in the whole MVI versus MVVM debate. So you can have people who are really, really keen on MVI, so model view intent with, like the React architecture, but the rest of the team is actually not really that keen on it, and they're more likely to want to use MVVM. And in that case, I think it's better to actually err on the side of caution and go for the one that the team is most comfortable with. I don't think it's very good if just one person on the team is really pushy for a complex library, and that's going to cause difficulty for the other developers on the team. So does that help answer the question?
Yeah, I guess like you have to just pick what's right for your team right there.
Yeah, I agree with that. Like, it's not necessary to use the most type-safe library. It's not necessary to use the newest library. You have to look at the team and then ideally fold them into this decision. So there's a question in the chat. What's the name of the library you use, Shalom? It's a result library. Is that correct?
Yeah, I can post a link. It's called Kotlin Result, which I suggest you read Adam Bennett's article on this because it's a pain in the ass to use, since the core class is called Result, and Kotlin standard library has something called Result. And so the auto import functionality in Android Studio will almost always pull the Kotlin standard library one and not the one you actually want. It's a huge pain in the ass. And he had some comment in his article about how to get the IDE to ignore the Kotlin standard library one, because sorry, that's just one part of using it that's always frustrated me. Only the name was changed.
Yeah, I did look at Result when I was making these presentations, and I just ran out of slides to talk about it. I thought that Result would be a really nice happy medium between using try-catch and then using Arrow. Like, Result is actually quite a nice way to do it. It's not the full Monty like Arrow, but it's halfway there. So there's a question in Q&A. Can I try and answer that question?
Go for it.
Okay, so question from Ramesh. Hi, Ramesh. I used to work with Ramesh. So does the Arrow library have any API to globalize the error handling? Do you have some suggestion on that? Okay, so I guess we're kind of thinking about the RxJava global error handler. I'm going to try and answer the question based on that. I actually think the global error handler is a little bit dangerous for RxJava, and it's something that you'd want to minimize instead of having exceptions bubble up and then go to a global error handler that's the last port of call before crashing the application, it's better to handle the exceptions locally and to map the exceptions. So I think in Android, we're really good at mapping between, like, say, a domain layer and a presentation, domain layer and presentation layer and so on for our data, but we're not good at mapping our exceptions. We just tend to let the exceptions bubble up right to the top. And that's something we want to prevent. So I would say using Arrow that there's almost no need for a global error handling. Does that help answer the question? So instead of global error handling, you have local error handling. So remember that when we were writing the repository, when we were writing the data layer was exposing a data source exception. And then when we got to the repository, we took that data source exception and mapped that into domain exception. And then we prevent the data source exceptions from going any further than the repository. So we're handling things locally rather than globally.
Okay, I'll mark that one as answered. All right, it seems like there's no other questions. I'm actually gonna hop on. If you're available afterwards, I'm gonna hop on a table with you. This is a topic I really love. Oh, we got one more from Ramesh. All right.
Okay, yeah. So question, are we duplicating the same handling in many places? Okay, that's a good question. So my thought on this is when you have a layered architecture, there's always going to be some kind of duplication. So for instance, your objects in your data layer might just happen to resemble the objects in your domain layer, but that duplication is accidental, and that duplication is necessary to maintain the separation between the layers there. So a little bit of duplication is actually desirable. It's a lesser evil than letting a whole lot of exceptions bubble up right to the top. Does that answer that question?
We get a thumbs up if it did. There we are.
So yeah, sorry, I'll say something more. I've collected my thoughts a bit. So I think in the Bob Martin literature, the Robert Martin literature explains the duplication that you might end up between layers, like having to map between domain layer and presentation layer or data layer and domain layer, explains that duplication is accidental, and a future requirement could come along that would cause that duplication to disappear. So that kind of duplication is okay. The kind of duplication that's really, really bad in software engineering, I reckon, is where you have business logic that is duplicated. So when you have to make a change to the functionality, then you have to change it in a whole lot of different places. Like that kind of duplication is very, very harmful. But duplication just of the sort of mapping between different exceptions or mapping between different objects is not so bad.
Cool. All right, marking that as answered, and then we've got one that just says cool. I feel like that's nice and supportive. All right. So on that note, thank you so much, David. That was wonderful. And I guess we'll see you all at the tables.
Thanks, everyone.
All right. Lots of love here. Okay. After the last reaction. Oh, more reactions. I'm just going to have to wait here until they're done. Too much love for you, David. We can't continue this event. Okay. Cheers, guys. Thank you.